Under secondary price discrimination, all consumers face the same options, but they might pay different average prices depending on how much they buy. So the prices don't differ by individual, only by the quantity that a person buys. So the monopolist knows there are different types of consumers but cannot identify them. So let's look at how second-degree price discrimination can be enacted in practice. So remember, under second-degree price discrimination, the average price might depend on the quantity. So let's start by looking at the sort of pricing we're used to. This is called linear pricing. So there's a constant average price P that's charged regardless of the quantity. So the total amount a person spends depends on the quantity, and it's equal to the price times the quantity. So the total outlay is equal to P times Q. So this is linear pricing. So in this case, the total outlay is a linear function of Q. It's just Q multiplied by some number. On the other hand, if the total outlay function is nonlinear, then we say there's nonlinear pricing. So an example of nonlinear pricing is what's called a two-part tariff. So a two-part tariff consists of two parts. The first part, F here, is an access fee, and that's like a fixed cost. In order to buy anything at all, someone has to pay F. And then for each extra unit they buy, they pay P. So P is like the marginal cost. So the total outlay under a two-part tariff is the access fee plus the price per unit times the quantity they buy. I should note this is only the total outlay if Q is positive. If Q is 0, then the total outlay is 0. They don't pay the access fee. Now, linear pricing corresponds to the case where the access fee here is 0. So when F is 0, we get the same thing as we had up here. If F is bigger than 0, then we have nonlinear pricing. This is a nonlinear function. It's what's called an affine function in mathematics. You might be used to calling these linear functions, but they're not really linear functions according to the mathematical definition. So the monopoly might offer one of these tariffs, or it might offer different two-part tariffs. So let's look at a simple example. So in the image here, we have the ticket prices for Gulliver's in Warrington, and you can see that in this example, the adults pay £17 at the gate. So in this example, no matter how many rides they go on, they pay £17. So all they pay is an access fee. So in this example, the access fee is £17 and the per unit price is 0. There's no price charged per ride. It's just a flat fee of £17 to enter the park. So this is a very simple example of a two-part tariff. Now, one thing to notice about a two-part tariff is that the higher the quantity, the lower the average price. So think of that example with Gulliver's. As someone goes on more and more rides, they're paying less and less per ride because that flat fee is spread over more rides. This is the case also when the price P is positive. So here we have two diagrams. So we have in this diagram the total outlay function, which remember is just the access fee plus the price times the quantity. The access fee here is the intercept. When Q is 0, this line is at F. And the slope of this line is equal to the per unit price. Now what about the average outlay? So this is like the average cost for a firm. We divide the total outlay by the quantity and we get the average outlay. And that looks like this. So it's the per unit price plus the access fee over Q. So the bigger is Q, the smaller is this. And as Q goes to infinity, this goes to 0. So we have this asymptote of the average outlay function to the per unit price. So there's a bulk discounting going on here. The average outlay decreases with the quantity. So let's think about the consumer's choice of how much to buy when they're faced with a two-part tariff. Well, the marginal cost under a two-part tariff, the marginal outlay, is just that per unit price. So actually each extra unit they buy is going to cost them just P. So this is the same as for linear pricing, and therefore we're going to have the same behavior as we do with linear pricing. People will consume up to the point where the price is equal to the marginal benefit. That is, we just read the quantity off the usual demand curve. The only slight wrinkle is, for them to buy anything at all, the access fee has to be small enough that they get a positive consumer surplus. So the access fee cannot be so high that the consumer doesn't want to buy anything. Okay, so let's think about the optimal two-part tariff in the case where we have either one consumer or lots of identical consumers with the same individual demand curve. So here we have the demand, the marginal revenue, the optimal quantity under uniform pricing and the optimal price. We have the competitive quantity and we have the marginal cost. Now let's think about this quantity QU. Under uniform pricing, the monopolist gets a profit of G. How could the monopolist do better with a two-part tariff but still selling QU? How can they capture this E here as profit? Well, all they have to do actually is to charge an access fee equal to E. So remember, under uniform pricing, E is consumer surplus. It's the difference between what the consumer is willing to pay and what they're actually paying. If now the monopolist charges them a fee equal to that consumer surplus, then the consumer surplus will be zero. And so the consumer will be just be indifferent between buying and not buying. And we assume that they do indeed buy. So the best thing to do if the monopolist wants to sell QU and it's able to use a two-part tariff is to price at PU and charge an access fee equal to what would have been the consumer surplus, that is E. So on the next page, we have here the monopoly. If they want to sell QU, the best way to do that is to charge an access fee and a price where the access fee is equal to that consumer surplus E when the quantity is QU, and a price equal to the uniform price there. However, this is not the best the monopoly can do. The monopoly actually can do better by changing its quantity as well as the way it prices. So let's look at the diagram again. And if you recall that diagram about the motivation for a monopolist to price discriminate, there's this area F here, which is deadweight loss when the monopolist produces this output QU. So the monopolist will actually be able to capture that area F as profit as well. So all it has to do is sell QC units, the competitive quantity, or the quantity where the marginal benefit curve or the demand curve crosses the marginal cost, and charge a price equal to marginal cost, so that consumers indeed actually want to buy this much. And then, well, if there were no access fee, consumer surplus would be E plus F plus G. But the monopolist can then charge that as an access fee, and the consumer would be getting a zero surplus and just be indifferent between buying and not. So the optimal thing to do here is to charge a price per unit equal to marginal cost, sell QC units, and make the access fee equal to E plus F plus G. So the optimal two-part tariff is equal to E plus F plus G, and the per unit price equal to marginal cost. The monopoly sells QC units and extracts all the surplus from the consumers. So a two-part tariff is just one form of nonlinear pricing. Another form of nonlinear pricing is what's called a price quantity pair. So instead of offering a whole schedule and allowing the consumers to choose any quantity they like, it might be the monopolist offers only a finite number of different prices and quantities. So a price quantity pair just consists of a total outlay, T, and a quantity. So it could be you can buy 10 units for £50, you can buy 20 units for £80, and so on. So that's a price quantity pair. So here's an example with Tesco cheese. So we have three price quantity pairs here. We have the price quantity pair £1.50 for 180 grams, £2.50 for 325 grams, and £3 for 400 grams. But consumers in this case can also combine these price quantity pairs and therefore consume different quantities to these three. In the examples we'll look at mathematically, we'll assume that this can't be done. There are only a finite list of options and the consumers cannot buy multiple options. So here's another example. This is KC broadband. And in this example, we've got 4 broadband packages. So let's just focus on the download limits here and the bit that says additional usage is just £2 per gigabyte. So if you go over the limits, you pay £2 per gigabyte. Now, we have this first plan, which is 35 gigabytes, and the price, the total outlay here is £31.99. So on the diagram here, we have the usage, this is the quantity, and we have the total outlay. And for that first plan, that plan in the diagram is in red, so that's the home plan. If they use none of their bandwidth, they pay £31.99, and they keep paying £31.99 up to the point where they reach their limit of 35 gigabytes. So that's this point here. Once they go over that limit, they pay £2 per gigabyte. So that's the steep bit here. So that's got a slope of 2. And it's a similar situation for the other plans. We have the total outlays here for the other 3 plans. And we have a kink at their limits. Now let's think about how a consumer would actually choose their quantity in this situation and their plan. So we have essentially here what are like budget constraints for the consumer. So in order to see which plan the consumer will choose, we actually have to also draw some indifference curves. Now in this case, they won't look like what you're used to because here we actually have a good and a bad. So the good is the usage of bandwidth. The bad is the total outlay. So a consumer actually wants to be down in this direction. They want to get more gigabytes but pay less. So the indifference curves are actually going to be upward sloping. And so let's draw some. And here, the highest indifference curve this person can get onto is going to be this one. And it's going to be at that point there at a kink. So a person with these indifference curves would choose the Home XL plan and they would end up consuming the limit for that plan. Now no one would want to go over the limit unless they had a very, very steep indifference curve that touched up here, right? So they might have a tangency up here. Most people are going to consume at these kinks. A person will choose to consume the home plan if they have a relatively flat indifference curve. That is, they're not willing to pay much for an increase in usage. So what we get out of this is that most people are going to consume at these points. So essentially, KC is offering price quantity pairs, 4 of them. So we can think of these plans just as price quantity pairs. So we've got the 4 prices, we've got the 4 quantities, and KC must have done some research and found that there are broadly 4 types of consumer, and these are the prices and quantities that they want to offer to consumers in order to maximize profit. So remember, consumers are free to choose any of these plans. They can't combine them, but they can choose any one of these 4 that they want. Those that have a high willingness to pay for bandwidth are going to buy this one. Those with a low willingness to pay are going to buy this one. And those who have an intermediate willingness to pay will buy one of these others. Okay, so let's now do the same exercise we did as with the 2-part tariff. So we're going to see what is the optimal price quantity pair if we have just one type of consumer or just one consumer. So here we have the same diagram to begin with. So let's look at the optimal way to sell this quantity QU. So remember, a uniform pricing monopolist would sell QU and get profit of G. How can they do better? Well, they could use a price quantity pair. So what would the price quantity pair look like? So we've got to find the price and the quantity. Well, we're looking at the optimal way to sell QU. So the quantity we're thinking of as QU. What's the optimal price? Well, it's going to be exactly what the consumer is willing to pay for QU. So if you want to sell QU and get the highest profit, you charge exactly what the consumer is willing to pay. Remember, we have one type of consumer here, so we know what they're willing to pay. We know exactly what to charge them. We're going to charge them the area under the demand curve. And the area under the demand curve is going to be E plus G plus this area here, which is C times QU. So the optimal price is E plus G plus C times QU. Now, we know the monopolist can actually do better than that. They can also capture this area F, and the way they do that is by changing the quantity. So the optimal price quantity pair is where the quantity is QC, and the price is equal to the area under the demand curve up to QC. So this whole area here. So it's going to be E plus F plus G plus this area here, this rectangle, which has an area of C times QC. So the monopolist is going to sell QC units and extract all the surplus. So there are two ways where a monopolist can extract all the surplus from the consumer and maximize their profit. They could either use a two-part tariff or a price quantity pair. And here essentially we're looking at the case of perfect price discrimination, because if there's only one type of consumer, then perfect price discrimination and secondary price discrimination are the same. They only differ when we have different types of consumers. Now, when there are different types of consumers, it does matter whether we're using two-part tariffs or a price quantity pair. And it turns out the price quantity pair is better because it's more restrictive. They have more control over the quantity the consumer can buy, and so they can get a higher profit. So next, we'll look at the optimal price quantity pairs to offer when there are two types of consumers.